Hi guys, so I'm here in Wolfram Math World and I'm on the Isodynamic points page, and I actually want to spend this video doing a Geogebra based construction of the two isodynamic points of a triangle ABC. Okay, so what this page explains is that these 2 points S and S prime, which are the Encyclopedia of Triangle Centers, are labeled X15 for the interior first isodynamic and X16 for the exterior second isodynamic. They actually they can actually be constructed via the intersection of these 3 dashed circles, which are known as the Apollonian circles. And to construct the first Apollonian circle, okay, this first one over here, going to vertex A, all you need to do is you need to draw this internal bisector from A, intersecting the opposing side BC at this point, labeled D21 on this drawing. And you also need to draw the perpendicular external bisector, intersecting the same opposite side, its extension in this case, at point D22. Once you get D21 and D22, you can simply draw a circle that goes through them, and they're going to be a diameter of the circle, and the base vertex A. And you're going to repeat this construction cyclically, obtaining the other 2 Apollonian circles. And these 3 Apollonian circles, or Apollonius circles, they will intersect in 2 points, so they're part of the same pencil. They intersect in 2 common points, which are precisely the first isodynamic point S and the second isodynamic point S prime. Okay, well, let's switch to Geogebra and let's try to go ahead and take a stab at this construction. Okay, so I'm going to draw a triangle ABC as the interior of the sort of 3 lines that I've placed down here on the plane. I'm going to use this concept of a triangle, actually 3 infinite lines in general position. And I have here vertex A, so let's go ahead and make these labels bigger so that everybody can see them. I'm going to make them 32 point. I think it's better. Yeah, so I have this general set of 3 lines and they're defining a triangle in their interior. And let's go ahead and do the math world construction for the first Apollonius point. So the first thing we need to do is draw, and before I do this, let me go ahead and make sure, no, I'm going to keep it that way. So let's go ahead and do the angle bisectors of the A angle, right? So here's the 2 angle bisectors, or angular bisectors. And so we can keep color coding consistent. I'm going to make these guys be gray, and I'm going to remove the transparency and make them be dotted lines, okay? And likewise, just for my own reference, I'm going to make these 3 sidelines of the triangle be blue, because I usually do that. My reference is typically a solid blue color. Okay, so I have my first set of angular bisectors of vertex A. Now I need to intersect this internal bisector with the BC line. So I'm just going to do this by clicking here. And I need to intersect the perpendicular external bisector. Okay, so you can see that this external bisector is perpendicular to this one. And in fact, it bisects lines AC and AB externally, right? You can see here that this line is a bisector of this angle over here, this external angle. Now I need to find the intersection of this external bisector with line BC, which is happening up above in the scene, and I'm going to make it come closer to us by just tweaking the position of B. So it's over here. Let's go ahead and find that point. And oops, just did not locate it properly. Now it has located it properly. Now all I need to do is draw the first Apollonius circle, which goes through these 3 points: the base vertex A, this first intersection D, and this outer intersection E. So let's go ahead and do that. Circle through 3 points. 1, 2, 3. And here's my first Apollonius circle, which I'm going to color in red just for clarity, and make it be a long dash circle. Okay, so I have my first Apollonius circle. Let's go ahead and now cyclically repeat this construction and find the 2 angle bisectors of vertex B. Oops, that's not how I do it. I actually do it like that. Let's go ahead and do that. I need to select this side and that side. And just before we do our construction, I'm going to go ahead and make sure I keep the same standard everywhere so it's visually appealing. By the way, I highly recommend when anybody's doing slightly more complicated GeoGebra construction to keep the color coding, to start maintaining it incrementally, not do it at the end, because very often you actually get into this rat's nest situation with too much information on the screen. So I like to build my color coding incrementally. All right, so what do I need to do? I need to repeat the construction. I need to find the intersection of the internal bisector at vertex B with the opposing side. And I can do this with a point tool. So I'm going to mark it off over here. And now I need to find the intersection of the external bisector with the same opposing side, or its extension, right here. And I'm ready to actually draw the second Apollonius circle by clicking on these 3 points. There it is. And let's go ahead and change the color coding on this guy. I want it to be red, red, and I always remove the opacity or the transparency, and I want a long dash. So here's my second Apollonius circle. At this point, you can notice here that I already have the 2 intersections where my two isodynamic points should fall. So I can already eyeball that the first one is over here and the second one is over there. Okay, but before we actually mark them off, let's go ahead and build the third and somewhat redundant Apollonius circle. So I'm gonna again repeat the construction, angle bisector on the C vertex, change their colors so I know what they are, like so. Okay, and I'll find the intersection. So I'm going to go ahead and do this intersection. So it's the internal bisector from vertex C with the opposing AB side. And now I need the external bisector of C with the extension of AB. And that's happening way to the left. So let's move our picture a little bit here. And that's the intersection right there. So let's mark it off over here. And now I'm ready to draw the third Apollonius circle passing through vertices C. Then this intersection H, and this outer point here I. Let's go ahead and change that color to red again. Make it be, and now I have the 3 Apollonius circles, and I can check if they indeed intersect at 2 common points, meaning that they're on the same, I don't know if this is called an elliptic or hyperbolic pencil, but they intersect in 2 common points. So I like to call them elliptic because the intersections are real, whereas there's this other type of pencil of circles where there are no real intersections, and I like to call that the hyperbolic pencil. But this one is the 3 Apollonius circles on the same pencil of circles, and now we can finally mark off these common intersections, which are going to precisely be the first Apollonius, the first isodynamic point, and the second isodynamic point, which was not detected correctly right there. Okay, so now let's clean this up a bit. So let's start by getting rid of labels. Okay, so I'm going to go ahead and select these 3 triangle sides. I'm going to get rid of their labels. I'm going to get rid of the Apollonius circle labels as well by selecting them. There you go. And now I can actually perhaps not show these intersection letters either. And now I have the 2, this one here is also spurious. This one over here, spurious. And there's probably something else. Yeah, there's still some labels here that I want to get rid of. So let's go ahead and get rid of these labels. And there's a better way to do this. You can actually get rid of all the labels in one shot and then just repaint those that you actually need. But I think I've done a manual job here that is decent. And you can see that I can move my triangles. And then finally, let's go ahead and label this guy here as S, which is equal to X15 of a triangle. There it is. And I'm going to make this guy take in perhaps the red color. And I'm going to label this guy here as S prime, which is equal to X16. There you go. And let's make this guy also be colored red. So there you have it. I have the two isodynamic points of a triangle constructed using the construction suggested in Wolfram's Math World. All right, see you on the next video.